Chem, today we are going to see a new question from stereoisomerism. Okay, this is the third question. We'll see the third question. The correct statement about the compound. What is the correct statement? This question is asked in 2009. Okay. See, this is the question. Here the double bond is there and one C hydrogen is there and another C. One second, I'll take the pointer so it's easy to visible. And another C hydrogen OH CH3 and three groups are attached to this carbon, and in the same way in this carbon attached to hydrogen OH and CH3 three groups are attached. Okay, we'll see clearly in the structure. See, this is a C double bond C, one carbon which contains three groups, that is CH3, OH and X. That's why they have mentioned within the bracket OH. Okay, if it is there, then this is the one of the substituent to this carbon. Okay, all these three are substituent to this carbon. Okay, and in the same way here. So this double bond clearly shows it's a geometrical isomerism like that. Okay, and here, what about is the question they are asking? The total number of stereoisomerism possible for this compound is 6. Total number of isomerism they are saying 6 isomerism. We will check one by one how many isomerisms we are having for this compound. Okay, see here. This is the compound. Okay, this is the compound, and this OH and H CH3 is there. So 4 different groups are attached to this carbon. This is the chiral carbon. Okay, and here see the spatial arrangement for this one, and this hydrogen is towards you and this is OH is away from the view, and this is also the same way. These two are the same. It's, see here, if you draw a line over here, the plane of symmetry is there, so this compound is having a plane of symmetry and it is identical, that is both the sides are identical, so it's a meso compound. So what is that? Meso compound. If there is any plane of symmetry is there for the compound, then that it is a meso compound. Okay, and if you change any one of these two, okay, whether here or here, okay, here they have mentioned over here, so we will take this carbon. Okay, you exchange this one, okay, in the view, then what will happen? If OH will be towards you and hydrogen will be away, so if you rotate this, then we will get this type of compound. This is not meso compound. There is a no plane of symmetry over here. Okay. Then if you take a mirror image of this compound, then two compounds we will get. That's why here they mentioned as 2 plus 3 as enantiomeric. Enantiomeric means mirror image of these two compound are called as enantiomers. They have a mirror image, but non-superimposable mirror image. That is non-superimposable mirror image is an enantiomer. Okay. So I don't want to mention that structure also over here. So just a mirror image. If you draw a line and just draw like this, this will come here and that will come that side. Okay. So two compound we will get, and this is the cis one. Okay, C double bond C. Both the compound will be, both the carbon are on the same side. Okay, so this is a cis compound. How we are saying a cis? If you draw, I'll tell you here. If you name it as A and B, this is a more value. Okay, this is having a higher atomic number. So this is as a A and this is B. Okay, and in the same way, if you take these two, this is A and this is B, and this is B. Okay. See here, the A and B are on the same side. So this is a cis compound. What is that? This is a cis compound. And if it is a trans compound, see, this is a trans compound. Okay, this is a cis compound. Both these things are cis compound. I'll write it over here so that it will be very clear about it. Right, both these are cis compound. Okay, and the same way both these are trans compound. Okay, trans compound. In this trans compound, if you check it, see this carbon and this carbon the opposite side. That's why we are saying as a trans compound. And if you turn this carbon like this, see here, OH, CH3 like this, CH3, both are the same. Like the same way, this is just the trans to that. This is a cis, so plane of symmetry will be there. This is the trans, so there is no plane of symmetry. In this compound, this is if you draw a mirror image, you will get another enantiomeric compound. Okay, so 4 and 5 or two compounds are there. If you draw a mirror image, you will get another compound. Okay, this is not the same. If it is the same, you cannot draw any mirror images for this meso compound. If it is not a meso compound, then you can get a mirror image of this compound. Okay, So 2 compound you will get. Okay. And in the same way, when you will get a meso compound, see here, if you exchange these two, okay, if you change this two, then you will get a meso compound. You draw a line over here, then there is a symmetry will be there for both the side. Okay, if you see, if you just draw a line over here, then see that CH is there, H is there. There is a center of symmetry is there. So this is the meso compound. Okay, then this is a meso compound. Plane of symmetry is there. So this is a meso compound. Overall, how many stereoisomers are there? Total number of stereoisomers possible for this X structure is 1, 2, 3, 4, 5, 6. 6 mesoisomers, sorry, 6 stereoisomers is possible. So the first statement is right. Okay, the first statement is correct. And the total number of diastereoisomers possible for X is 3. Diastereomers means what? Mirror image of the enantiomer is enantiomer, mirror image of this compound is enantiomer. For this also the same. If these two, opposite to these two, will be the diastereomers. For this first one and this one, and for the mirror image of that two, okay, that two will be the diastereomers. So overall, diastereomers is also 4, but diastereomers as 3 is wrong. Okay. If the stereochemistry about the double bond in X is trans, so they are asking about the trans, the number of enantiomer possible for X is 4. This is the trans. Number of enantiomer is how much? Only 2. It's not 4. Okay, 2 enantiomer is possible if it is trans position. Okay, if they are asking overall enantiomer means then it is 4. Okay, if only for trans means only 2. If the stereochemistry about the double bond in X is cis, the number of enantiomer possible for X is 2. If it is a cis, number of enantiomeric form, this one and at the mirror image. So 2. That is right. If it is a trans or cis, the enantiomeric is 2 plus 2 only. Here plus 2, here also 2. So 2 enantiomeric form is there and 2 cis form is there and 2 trans form is there. Okay. 2 cis form is there and 2 trans form is there, enantiomeric form. So this is also right. So the answer is A and D. A and D. If you are not subscribed to the channel, please subscribe to the channel and click the bell button so that you will get all the questions, upcoming questions on the NEET exam. And this is very, very helpful for you, those who are going to write the exam and preparing for the exam. Don't miss it. Watch. Thanks for watching.